All right, we are going to review factoring together. So if you want to take some notes, write a few examples down. This is what you learned in Algebra 1, but I know it's been a while, so let's look at some of these together. So what in the world is factoring? Well, take a look right here. Before you learned how to factor, you probably learned something called FOIL. That's when you're given, like, for instance, two binomials like we have right here. You had to multiply them out. Sometimes it's called FOIL, right? It stands for first, outer, inner, last. And then after you FOILed them and simplified, you'd get something like we have over here, a little trinomial sometimes like this, okay? Then after you learned about FOIL, you learned how to factor, and that just takes FOIL and undoes it. It basically does it in reverse. So you take this trinomial, and then you'd have to get from here and get to your factors over here. Find those factors that multiply to give you that trinomial. So let's take a look at an example. Start with a pretty easy one right here. So you can go ahead and write this example down. We're first going to look at factoring trinomials that are in the form x squared plus bx plus c. Okay, so these are ones that they don't have a leading coefficient. So there's not going to be a number in front of the x squared other than the 1 that's assumed that is there. Okay, so there's a whole lot of different ways to teach factoring. Some teachers do like a box method. Some teachers do a T-chart, right? And you like list out the factors. Others organize it, and this is a really common one, like an X chart like this. So if you have a way that works for you that you like, you can totally use that. I'm not going to review all the different methods because there's so many of them. But ultimately what you're looking to do is you're trying to find two numbers that multiply to 12, always this last term, and add to give you 7, the coefficient of your middle term. Okay, so if you want to pick one of your methods, we'll go with the little cross method here. This is just a way to organize the information. So we're looking for numbers that multiply to 12 and add to 7. Okay, so this is a pretty easy one here. If you think about it for a minute, you're going to get 3 and 4. Okay, so this is, again, just a way to organize the information. But once you find those two numbers, 3 times 4 is 12, 3 plus 4 is 7, that's most of the work. You just have to set your factors up. Okay, so to set up our factors, we're going to have two sets of parentheses. These first two terms, well, think about if you were FOILing. What times what would give me back this x squared? Well, x times x would. Okay, and then we have a positive 3 and a positive 4, so we're going to put plus 3 and x plus 4. And it doesn't matter the order. I could have switched those, and that would be totally acceptable. And those are your factors. You're done. Now, you probably remember solving these problems. If there had been an equal sign in this and they said to solve it, so let's say it said equals 0, then you would have a couple more steps after this right here to actually solve it for x. But it doesn't have an equal sign. It just says factor it. So once you get your factors, you are done. Let's try another one. Example 2 right here. So if you want to pause this and see if you can work it out yourself and then check your answer, go for it. But we can set up a little chart here. We are looking for two numbers that multiply to 27 and also add to it negative 12. Don't forget the negative. So think about that for a minute and what that could be. Maybe some kind of 9 times 3, right? And then think about where negatives would go. Well, in this case, it multiplies to a positive 27, so either they're both positive or they're both negative. And in this case, they will both be negative because they also have to add to negative 12. All right, so we got our two lucky numbers. So we set up our factors. One of them would be x minus 9. The other factor, x minus 3. All done. Not too bad. Hopefully some of this is coming back to you now. Try another one here. Go ahead and write this one down. This one looks a little bit different, right? In this case, we do have a number in front of the x squared, but take a look at all three of our terms. If you notice, we actually have a GCF, a greatest common factor, and that GCF is 5. We could factor a 5 out of all three of these terms here. So anytime you have a GCF, you need to factor it out. In fact, it'll make your life a lot easier because you won't have such big numbers to deal with. All right, so let's start with factoring out this 5. So I'm going to pull a 5 out, do my open parentheses, and I'm going to write what my remaining terms would be. So basically, you're just dividing each of these terms by 5 and writing what you have left. So if we divide this one by 5, we'd be left with x squared. And you can just think of it in reverse. If you're distributing, 5 times what would give you 5x squared? Well, 5 times x squared would give you 5x squared. Okay, then here this would become 5x, right? That makes sense. 5 times 5x gives me that 25x. Then my last term would be 4. 5 times 4 would give me back that 20. All right, so pulling out this GCF made things a lot easier because we no longer have a number in front of x squared, so we can factor this just like we did the other ones. And this is a really easy one. If you want to set up your chart, you can do that. A lot of you guys can just kind of guess and check this without doing the chart now, since this is a very simple one. But you're looking for numbers that multiply to 4 and add to 5, which that would be 4 and 1, right? 4 times 1 is 4, 4 plus 1 is 5, both positive. All right, so one thing here, whenever you factor out a GCF, it doesn't just go away. You don't just toss it out and never see it again. In fact, you need to bring it down with you into your answer. Bring it down every step of the way. Okay, so we'll bring down that 5. We won't forget about that, and we'll set up our factors. 1 would be x plus 4 times x plus 1. There we go, all factored. Just make sure you don't forget about that 5. Now, if I wanted to check my answer here, I mean, there's, multiple ways you could do it, but I would maybe like cover up the 5 and just FOIL these out, and then multiply all of those terms by 5, and you will get your original that we have up here. All right, awesome. Let's see what else we got. Okay, different kind of problem right here. It says, what if the coefficient is not 1? What do we do? So go ahead, write this example down. This is going to be different than the other ones we just looked at. So it says factor 5x squared plus 31x plus 6. Now looking at this one, think to yourself, do we have a GCF? Well, unfortunately we don't, right? I can't factor 5 out. There's no GCF we have here. So we're going to have to do this problem a little bit different because we have this 5 in front of the x squared. Now, I'm going to stop this video, see if you remember how to do this type of problem, and if you don't, no worries, we'll pick it up in the next video.